So I bought a new piece of equipment, and this one's a little bit different than what we had before. Oh, welcome back to the lab, welcome back to E for everyone. This is interesting to me. It's a lot like what we had before, only different. And I want to show you some differences, but we just did this video, so I'll cut to the chase. This little piece of equipment is a certifiable death trap. I really don't know how I feel about this piece of equipment. On the one hand, I suspect this one will also struggle. Looks like they actually tied it to Earth. How about down here? Post is struggling for some reason. Guess we'll have to take it apart. Before we tear this thing down, I just want to talk about some of the complaints I've heard. The first complaint I've heard about this thing is that it's not flat. And I set something big on it, and certainly it is not flat. For a small board like this, it seems flat enough. But if you try to use the whole area, you might be disappointed. Then again, maybe it's me that's not flat. And oh no. Anyways, before I dive too deep into that existential crisis, let's tear this thing apart. Wow, there is really not a whole lot going on in here. You get this temperature control unit that seems to clip in somehow. This front controller. So that seems like a standard module that we could replace or upgrade, which is cool. And I really, really hope this is the thermistor because those wires are, well, really small. Yeah, we're going to just tell ourselves that's the thermistor. Besides, there's all these other wires that are probably going up to little heater elements up in the top. Power switch has a nice ka-chunk to it. They don't have any wires labeled here, but they've got line and neutral coming out. Both poles are actually switched, which is nice. You completely disconnect mains from this thing. And like usual, everything is connected to, looks like line. Then they have a switched output. Yeah, I don't know how this thing works, but seems reasonable, and they've got this crimp connector carrying mains down to the heating elements. My count would say 4 heating elements. Overall, I like the construction of this thing a lot better than the last one, but I'm not gonna lie. This little current carrying conductor, 20 gauge wire. Let me run some math. Yeah, that's going to make a better fuse than a ground fault circuit interrupter. I think we're going to have to fix that. No star washer. Wow, that is a miracle that thing even made continuity. All right, I'm going to go get the crimp tool. I'm going to go see if I can find some star washers. We're going to replace this with something worth having. Well, I went digging through my wire, and all I have is hookup wire. You know, here, leave it to me to be complaining about their ground bond with this puny little cable, and then all I have is this lamp cord. I mean, at least mine's, 18 gauge? 18 gauge is a lot better than 20. That can't be 20 gauge. That can't be 20 gauge. Not a chance. There's no metal in there. There is no way. All right, I'm going to check the spec on this. I'm going to check the cross-sectional area of 20 gauge wire. There's not a chance this meets that spec. Comparing this to an 18 gauge, no way. This won't be official, but okay. I've got the wire, got the calipers. 20 gauge should be about 0.8 millimeters. Getting 0.64, but this is stranded. So I might have just kind of 0.6-ish. Seems a little undersized. This 18 gauge is very 18 gauge. I'll clamp. So you're supposed to clamp it where it's ground at the front. I'm getting about 1.14 millimeters on this 18, which is right in line. It should be about 1.02, but I twisted this. It's stranded. So yeah, that's a pretty anemic wire. Let me check. For a ground bond, I think you want to have at least like a 16 gauge wire. Holy crap. This is 8 gauge, but I think that's talking about panels. Yeah, there's a test for it. We don't have a ground bond tester. If y'all throw like, you know, $5,000 at the channel, I'll gladly buy a ground bond tester, but nah, I don't think that's gonna give us much value. I mean, we could just start doing like product safety testing, but then I'm just duplicating what safety agencies do. There's no point in that. Yeah, so at any rate, we have a real 18 gauge cable replacing a kind of sketchy other tail. Let me get this kind of prepped, and then I'll show you what I'm gonna do. All right, I didn't find anything perfect. This is really, I need to get some better washers and stuff. I was just digging through the box, trying to find some stuff that seemed to fit well. I found a star washer that should at least make good contact, and for those at home, the reason why I want to use one of these, of course, it's going to add some impedance, but I'm hoping this can cut through the paint a little bit better. The other alternative would be to file away the paint. Just hoping to let that dig in and, you know, just hold everything in place a little bit as well. We're going to do something a little bit sketchy. I mean, yeah, same thing they did, right? Got to crimp 2 wires into 1 terminal eventually. And we're using 1/4 inch, which I do believe I have. Now, it should be pretty easy. I've got the old color-coded crimper, so you don't twist these together. And yeah, you can have a lot of issues when you crimp multiple wires into the same housing. Generally not recommended. Yeah, I don't know. I don't love it, but I don't see what else I would do. I mean, of course, I could solder it, but you're not supposed to solder ground connections like this. I guess you just have better strategy. Yep, well, didn't work at all. Hey, remember that time that I felt like an idiot? I have a crimp connector that is made for exactly this. How about we use that one instead? Seems like a great idea. That way we can get some nice, good crimps. Well, that's not going anywhere. I'm pretty sure that this is also not how these crimps are supposed to be done. I'm about 98% sure that you're not supposed to have like daisy-chained crimps or anything. But when I look at what our options are where they want to ground 2 separate things, that's where I'd need to spend a great deal of time reading the standards, figuring out what's best. I know that's not best. I know that this is going to be better than that, but that's setting the bar pretty low. All right, so that's kind of the end result here. Got our 2, and yes, I know it's not a green wire. I don't have any green wire. Yeah, we definitely need to stock up. If I'm going to keep buying equipment like this, I really need to stock up on grounding wire of an appropriate gauge. Just checking the connectivity. Looks like we had some successful crimps. Okay. Let's put this on the spade. There we go. That looks pretty good. All right, now here's the real test. Did that 1 wire just do better than the previous 2? Because if that just grounded the top plate and the back plate, Oh, it did. Yes, that star washer bit through the casing, or bit through the paint, and is now in contact, and also... So already we're doing better than we were. Great. But just for some insurance, let's go ahead and put that second one right where they had it. All right, well, that hole is complete garbage. It just stripped out when I tried to tighten the screw. Thankfully, they gave me another hole right next door. And it's not actually tapped. I think that's where the problem came in. They used a self-tapper. And I do have a self-tapping screw in my kit. Give me a moment to find it. Oh, don't hide on me. Yeah, I bought a box, just a pound of random assorted hardware. It's one of the best purchases I have ever made. When you just need one random screw, dig through it long enough and you're bound to find something good. And then lose it again. And wonder where it is. Okay, let's try this. At least now I can get it as tight as the other one. Okay. We've got a star washer. Hopefully making contact. We're crossing our fingers. We've got both of those darn tight. If I had a torque wrench, I would torque them. But both of my torque wrenches are in a much higher range. That is, they're made for a lot more torque than even what my drill is set to right now. I would strip that out in a heartbeat, even on the lowest setting of my torque wrench. I need like a torque screwdriver. Okay. So let's take a look at what we've got now. So for better or worse, this is what we have. We have the same setup up here. All their current carrying wires seem fine. We've got line of neutral still switched. The ground of our power entry module comes over to the chassis over here. It also loops around and goes to the chassis and then through one of these mounting posts up to the top. So in theory, it ought to be grounded. There must be an oxide layer or something, because it's carrying ground up to the top. I know it is connected. There's no way the top is grounded if those posts are not. So, all right. Yeah, so I've seen a lot of people complain about the grounding not being very good. I can see why in the manual, literally in the manual, first line, please make sure the ground electrode connects well before using. Why? That should not be on the user. Then it talks about using it as an LCD heater. It talks about how to change the value and stuff. It seems fine. Claim it goes up to 400C. This should be cool. This should be really, really cool. And I could disassemble this further, but I'm honestly terrified that I'm going to destroy it. So, I guess leave some comments down below if you want me to destroy this thing and tear it down all the way. Assuming this works out, we're gonna jump down to the shop and try to heat this thing up and look at the temperature regulation. I got some thermocouples, so we can actually do that, test it properly. It'll be awesome. So we'll get the thermocouple tied in. We'll do some temperature regulation testing. We'll try to reflow board again. And then, maybe, just maybe, we can make some motor prototypes. Yeah, so I've been made aware that I'm an idiot. or at least my little monkey brain forgot something very important. Yeah, so metric and English, they've got these different temperature units. I got them confused. I set this thing way too hot. And actually, that really exposes why that other one was so bad. I set it to 400C. You only need to get these to like 250 to make solder flow. Why? Why was that so difficult? I don't know. I will never know. But, so here's what I'm doing. I looked at a teardown, and I really don't know why this was smoking. I think it's just the heater cartridge. Something about the cartridge is what's going on. And I saw some people that are using these to reflow boards, and I'm just going to try to duplicate what they did, because what they did seems reasonable. And, well, I like reasonable plans. Basically, what they do is they heat up the reflow plate to about 180-ish. That's kind of where they leave it. Now I'm cleaning off some of the flux that I left on this board when I put it on the hot plate. Oh yeah, there's that familiar smoky smell. So good. Love that. Can I see the smoke wafting? I cannot. We're up at 90 degrees. And they did confirm the construction, and I can tear this apart. I just haven't, because I was cranking it up to like 300 C when it only ever needs to get to 250 to reflow a board. But what they recommended doing was getting the hot plate to about 200, 180, setting the board on top of the hot plate while turning the heat up to 250, waiting for the solder to melt, and then letting it cool. That'll follow a decent reflow profile. Okay, we're up at 140. It's really not a bad heat time for being a giant metal plate. Yeah, it must have been some kind of heating element or like burn-in, because we're up at 160, and this thing was smoking last time we turned this on, and it did not. So whatever's going on must have burned off some kind of manufacturing thing. Okay. So here's where we're at. I'm now going to bump this up to 270, because I've noticed the controller cuts short about 20 degrees too soon. I'm going to drop that on. I'm going to hit go. Oh no. Okay, so now the plate is heating up, and we should see it reflow these boards. Or rather, this board. Okay, I'm smelling that burny smell again, but I'm not seeing any visible smoke, so that's an improvement. Starting to look promising. And now this is where, this has a nice square structure, so it should be easy enough to put a little box around this and make it nice and enclosed. Oh, we are close. Oh, there it is. Oh, yes, that is promising. Oh, that is promising. Oh, yeah. I just switched off the hot plate. Of course, some heat will be retained. Yep, touching those solder joints was a stupid thing to do. Awesome. Now that worked a treat. Now this is where, right, I'm imagining the final state. Final state for this, I would say, would be some kind of setup where you have a frame around this and a little tray you can pull in and out. Because if you can have a tray that's hovering just above or maybe in contact with that lower plate, that will allow it, you can get a convection fan in there, and it has this nice outer area that's basically free to bolt stuff up against. A little bit of insulation, and you have this nice big heat radiating plate that you can use to not totally screw things up. But yeah, I mean, I just pulled every part off that board. So if we have a solder stencil, like I ordered a solder stencil, we can definitely make this board. In fact, let's do that right now. All right, so we've got this all preheated. All I've got to do is put our fab on there. And would you look at that? One nice, perfect assembled prototype for us to play with. Well, why don't we go check this out upstairs? Man, Reflow is just so convenient. But as long as we're here and we've got this ready to go, let's wrap this up. Let's show you, well, at least where I'm at today. We have this little serial board that lets me use an FTDI module and functions as a power injector to power the motor modules. This is just for the logic, not for the motor. I've got some of these cables we just made. These are nothing crazy special. They're just, a straight through. They're not a crossover cable, and they allow for powering the motor modules. Then, of course, what is a motor module without a motor? This is the kind of motor that I designed this to work with. You can find some of these for cheap, and I printed the pinout in silkscreen there. So motor plus and minus are these cables right here. We'll plug that in. There we are. That gives us the Cypress P-sock. This is motor power in. We don't have any of that right now. Okay. We've powered on the system, though not much is happening. Positive to positive, negative to negative. And if we plug in the motor, you can see that little LED blink. But what does that even mean? Well, allow me to demonstrate. As I rotate this motor clockwise, you can see, can you see? Oh, I hope you can see. The motor LED is blinking. It's right there. As it spins right, it's reading the encoder, and it's giving us pulses. If I spin it the other direction, it gives us that little heartbeat, that double heartbeat with the same interval. And what that heartbeat means is that it has detected we're moving counterclockwise instead of clockwise, which is pretty cool. That means that we are able to sense speed and direction. Now I need to get some interrupt stuff going. I need to get the PWM driver working. I need to finish porting over our software to the Cypress PSOC line. But this is looking great. And for those of you at home that are calling me out for this and that and lying and stealing, and okay, yeah, fine. I assembled this manually while we were waiting for the new Reflow setup to come in. But it's still super promising that the hardware seems to work. So, of course, in our next video, we'll probably try to do a Reflow. I'll actually do the solder paste application, and I'll build a couple of each of these boards. And that should be really, really cool. Well, we have a stepper motor driver as well as this brushed motor driver. And just so you know, this has pads for an Arduino, so that should we want to remove the FTDI header, we can replace that with a programmable microcontroller that can then automate sending and coordinating some commands between multiple motor modules where a simple UART may no longer be an appropriate interface. But of course, this will let us use Python and everything else to talk to this system, which should be great. Yeah, I think that's all I've got for today. I have a lot of work to do with this firmware development kit, and we're going to talk a lot more about that in our next video. You can see I grabbed one of our dev kits and sacrificed it to the cause, so we can use this as a programmer for our different modules. You just plug that in and boom, all of a sudden you get an in-circuit debugger programmer. Seems to work really well out of the gate. It's actually looking really promising. I'm happy with what we've accomplished so far. So without further ado, I hope that you learned something great today, and I hope to see you again soon. This was kind of chaos, super fun, just kind of casual, but man, am I excited for the next steps of this project. We're going to get this thing running with Modbus and doing some closed loop control, and I might have bought a linear axis to play with as well. So we're going to have a lot of fun here for sure. I can start to demonstrate some differences between a real system and an ideal one, or a loaded motor compared to a motor with very little inertial loading. So anyways, I'm excited for all that and more. A special thank you to all of you who support the channel in any way through watching, commenting, subscribing, sharing what we do with others, or supporting us directly as a channel member on Patreon or YouTube. That support really helps us to do great projects like this one. Thank you. Thank you for supporting us directly. Well, I'll see you in the next one, and you know it's going to be good because we are off to a great start here. Bye.